I said, wait a minute, 15 doesn't divide by, or 5 doesn't divide by 2, but it's not. It's the same way when you're doing the other one, tens, you know. Oh, then, I'm going to explain this diagram because you're probably tired of listening to me. If you're still here, thank you. The arrows pointing out, the purple arrows on this phase, are ones that aren't connected. Three-phase things, I don't care if it's alternator in your car, or it's your stator on your wind turbine, or three-phase homemade motor or whatever. 2 of them are connected in series, one going in, one going out. That's the 2 legs of the Y, the 2 parts of the delta. The other one's disconnected. And then it changes. One of those will be swapped for the other one. So a 30 coil alternator generator or motor, it's got 10 and 10. It's 20 active coils and 10 off. That's why you can use zero crossing to switch your power from plus to minus. The way this thing works, and if you're going to try to understand this, you get 2 pieces of paper, fairly large. You draw your magnets, and space them. You put coils. You can draw round magnets and round coils like it is here because you can do it with a compass. Just do it for one phase. All 3 of them work the same. So you do it for one phase. And you can look through the holes in the paper where your coils are, and you can watch the magnets go. You put a pin in the middle so you can turn one piece of paper while the other one's staying still, or one piece of poster board is one way to do it. When I was using this, I would pick the center as the center rotation, and this one handle is for one set of coils, and this is for the other set of coils. But one will be blue and one will be red. But I can drag this around and watch all these things spin past the holes. Where you have like a red coming to a red. If these are opposite polarities trying to turn that way. And this is when I come up with the 2 coils counterclockwise together here, which makes 2 of them 2 clockwise at the bottom. It can't be any other way. At least I haven't found any other way. And if you look at that going around this rotor, these 2 would be attracting. These ones, the magnet and the coil, are opposite, so they're repelling. So this one is also trying to turn the same direction. See this arrow, this red arrow on this red coil is trying to make it go that way. With this arrangement, every coil was working with its magnet to turn it in the same direction, to generate electricity in the same direction, or to turn the motor in the same direction. This has got 2 phases shown, and the other one, I have a mask that fits over this that blocks off, it just covers up the one set of coils. This makes a blank space there, so you can look at the 2 that are going to be working from this rotor position to the next rotor position. But this wheel, well, I invented this wheel, but I got the idea from the guy who was trying to explain that free energy molar device. And, spinning a rotor in a vacuum with no load on it, what do you expect? It was going to turn until the air resistance of what's in there would slow it down, or bearing resistance. The reason it does what they thinking it's doing, with no load of course, is when you turn a coil on, you get inrush current flow until the coil reaches coil saturation. It's approximately 3 times the steady state current of a coil. We know that from electric motors when they stall and they pull 3 times their amps and they go up in smoke. That's why we have heaters on the output. You have a solderable disconnect, and the heating coil heats that solder and melts it before the motor melts down. So you have the inrush power going for you. Second thing is if you magnetize a piece of metal in high school, wrap a wire around a screwdriver, when you cut the power off, that screwdriver will still hold nails or something on the end for a couple of seconds before the magnetism decayed. So you're getting residual magnetism, they're getting inrush power from changing from positive to negative. And that's what you're seeing with those demonstrations. The thing itself, I seriously doubt it has any effect. Put a load on it with a flashlight bulb and it would stop turning in about 2 minutes probably. Even with all that weight. It's a huge amount of weight on the thing too. Okay, so what you're looking to do here is do one phase. The holes for the magnets, and the magnets, the reason the magnets are changing is you got a different number of magnets than you got number of coils. So if you make a piece of paper for one of your phases with your coils and then your magnets at the right spacing and turn one to the other, find out if any of them are trying to turn it backwards. If I take, on this case, my left half and flip it over, that'll change me from this coil here is clockwise. I would be getting a counterclockwise coil down there when I flipped it, because this top becomes the bottom and the bottom becomes the top. And all of a sudden you'll see that 3 of these 5 arrows are working against you in one way or another. They're trying to buck the flow. Now if you were doing a generator, you would have the plus voltages cancel out the negative voltages. So that means that it averages, they're varying amounts, but if you take all the combined amps of them in series, they're going to cancel out 2 of the 5 on the other side. So your average 3-phase alternator is severely hampered by the phases, the coils on the opposite side, which are magnetized, and the magnets are still magnetic, but they're working the wrong way. So this little trick of flipping the half to rotor over, and that's the reason I don't want to have to build 4 or 5 rotors to get this exactly as efficient as I can make it. So we came up with it's the same idea. We have, I didn't say before, see written in red, that's CW, it's clockwise. There's a clockwise in front of all 5 of those coils. The other half, if I connected positive, negative, and the current went through the whole thing, the other half is in front of clockwise coils. They're written in black. See, a green counterclockwise, and here's a green clockwise, because they alternate clockwise, or counterclockwise, clockwise, counterclockwise, clockwise, just like the magnets. They alternate. And I'm thinking that's the deal I want. It's drawing up the way I'm going to put it together. And because I want to be able to change this, these are just going to be brass bolts sticking out of the plastic, out of the epoxy, where I can connect the wires I want to make them either series or parallel, and then the remaining 3 wires are my 3 phases coming in. Down here at the bottom, there's things you can do down here too. This first iteration, all I want to do is continue the electric across from one side of the plastic to the other. So this wire really went to there. You know, before I ran them to the edge, this blue wire would have, all these wires would have continued right across. I swung this some of this stuff around. Well, this side here, I swung them around instead of pointing straight out, so I could draw it and it wouldn't be all crowded together. But this is wire. All I really have to worry about is this little point right here and where they come out of the coil. I can bend the wire any way it wants to go. I can bend them all and lay them on top of each other in the first inch of the width here, and probably will, you know. But anyway, this stuff was just shoved over so that I could make this connection, you know, of those 5 coils down through here and get across this this seam right here, which divides. I'm pretty sure that covers this, and I think the title is true to the title on the video that I'm attempting to use. Don't you think that looks like artwork? I mean, it looks like a perfect tablecloth to me, especially for an engineer. Oh, people always want to see who they're talking to. We're gonna make a change. I don't know, I think the camera's on that side. Welcome to concrete house building in the Philippines. We're old as dirt. I remember when dirt was invented. I thought it would be a great initial public offering. It had a lot of uses. You can walk on it. You can plant things in it. You can throw it at other people. You know, it seems like a really useful material. If I'd have bought dirt or Microsoft, I could be retired. But as it is, things didn't work out that way. So I need to do a video on how to design turbine blades, fan blades, all those kinds of things, where you're trying to either move air with a fan or capture air with a turbine, with a wind turbine. And I don't care whether it's a vertical axis or vertical or horizontal. You know that a flat slab tilted at an angle will move air and will capture some energy out of air. People are selling turbines every day with blades that are just flat slabs. Your ceiling fan, it's a flat piece of plywood at a very slight angle. Of course, it only draws 65 watts, you know. It's if you put any real shaped thing there, it would take a lot more amps to turn it. And then your electrical bill would go up and they wouldn't sell very many of them. So, y'all have a nice day. And yeah, there are videos on this channel. There's probably an icon near the video someplace you can click, and it'll take you to the channel. We're so unpopular that the channel name is Concrete House Building in PH, like the post office version of the Philippines. House Building in PH. But I don't think it's going to come up because, like I say, we only get 5 views, and some videos have 0 views. But if you find that icon, you can get to the channel and you can find about the vertical wind turbine. It's got a pretty good explanation on it. And there's other videos about wind power and our fan. Like I say, the big expensive parts are already fabricated. The blades are styrofoam covered in fiberglass. No major money there. You hot wire to foam and put glass on it. And the magnets are bought. The magnet plates are bought. All the bearings are bought. I haven't wound the coils. Right now I'm thinking number 18 wire, but I want to limit the actual coil to 1/2 inch thick and a 5/8 thick stator. And I can't get enough turns on there to run 48 volts. The inverter I have is a 48 volt inverter. And that's a problem. I can run this fan on 36 volts, but I have to run it through a step-down electronic voltage reducer. No major money, it's $3, you know, for one this size. But I was trying to just make it more simple. Run it right off the 48 volts and just switch the phases to run the motor. But this has same stator for the generator. No real changes to it except we want to be able to connect the wiring externally from all the coils to do different things. Two separate alternators inside the same piece of plastic. want to be able to change the coils from clockwise to counterclockwise, like all clockwise or all counterclockwise. There's just some things we want to be able to do with it, and splitting it in half allows us to do that. Okay, y'all have a nice day. I'm going to try to turn this off.